Hi everyone, welcome to KS Tutor algorithm. And in algorithm, we see many topics. So first topic is time and space complexity. Space complexity. Uh, Time and space complexity, we cover these many topics. First topic is introduction to asymptotic notation. Second topic is time complexity analysis of iterative program. Third, time complexity analysis of recursive program, comparing various function to analyze time complexity. And fifth one is master theorem. And sixth, analyzing space complexity of iterative and recursive algorithm. So first I cover only what first topic, that is introduction of asymptotic notation, that we see in what deep manner, but actually what is the meaning of asymptotic notation, how why we require asymptotic notation in these days. Let's start uh, our first topic, introduction to asymptotic notation. Before starting asymptotic notation, first we need to understand what is the algorithm. Actually, what is the algorithm is that, for example, let's take one example to understand what algorithm meaning is there. First read the statement first. Algorithm is a set of instructions designed to perform specific task. For example, you need to buy one phone, okay, mobile phone, and your per month salary is to 5k, but that phone cost is 30k, okay. But after expenditure, you save only what, 2k per month. So what you do that time, you started a new plan, and you just make a make a planning like that. If I making every month to 12k, so how many month I will buy my phone. According to this, after 15 months you can buy your 30k phone. So in this scenario, what you making, are you making this procedure like that? So this procedure is we call as algorithm. What do we call algorithm? Algorithm means you set of instruction that that you making a that every month 2k, if we save after 11th month, what you execute your task means you buy your new phone. Okay, so the set of instruction means you making a plan like that. If I make 2 to 3k saving per month, after a few months I can buy my new phone. That is your instruction. So same like in machine, you also making a some instruction and perform some tasks. So that's a particular work we can call as algorithm. So I hope you understand what is actually algorithm meaning is here. So next is complexity. So time complexity is quite what's similar is as time, like for example, if you want you perform something, so you spend some time, like same way algorithm also same work like that. So time complexity, we can say, quantify the amount of time taken by algorithm run respect to size input. Like here, size input is what, for example, per month you saving 2k, like, so how many time you execute your tasks? 11 month. If you input size is 3k, then your month time is always going to decrease, is going to, I guess, 11 month. If you save 3k per month, same like it's depend on input size. If your input size is good, then your time complexity is also good. So same way, that is the example to clarify to you what actually time complexity is there. So same like what is the space complexity? So if a machine executing something, they need some space to execute their tasks. So for example, I say that uh, to execute some program. Okay, so it's need some space to perform this task. So where is this space coming? That time we need some space now. So, space. So that time what we do? We going to processor, and processor going to where? Primary memory. You know what is a primary memory? Primary memory is we called as a RAM. So in RAM, if for example, if our 1 GB GB is for what storage to executing some our program require space, but in RAM 112 12 MB, so it's not possible to execute here. So that time we also what consider space complexity also. But nowadays what is happen now, we have not much problem about space. So that's why we totally means somewhat we neglect the space complexity, we only consider as a time complexity. So if our program is running good, then we can say our algorithm is good. Because in nowadays, everyone, the artificial intelligence require more space because the data consuming. So that's why the space complexity totally neglected. But we only focus on what time complexity. So uh, as we uh, as we see that we understand what is algorithm and time complexity and space complexity. So now in next slide we see what is the actually meaning of the asymptotic notation. So so what is the asymptotic notation? So if you understand that if we show someone to this is a thing, so what are you doing? You giving us some symbol like that, understood? So that time what you do, you say that for example t is denote for time. Okay, you say like that, yeah, it's in time. So same like that. So how you denote your time complexity? You need some notation. So that notation, if you show in some pen paper like that, you can say that this is called what is called asymptotic notation. So here if you read a definition carefully, you understand that what is the meaning of asymptotic notation. So as we read here, when it's come to analyze complexity of any algorithms term to be time and space, we never provide the exact number to define time required and space required by algorithm. Instead we express using some standard notation that I already told you that if we express in some standard notation, we can say it is what standard notation. It is a asymptotic notation. So if we represent some notation, that is called asymptotic. So if we it is a three types. So it is three types that we mention here. First type is big O, big omega, big theta. So what is exactly meaning of this what notation that we see in upcoming slide? So first is big O. Big O is means we can say that big O is a finding asymptotic upper bound. Upper bound means we can say that at max. Quite familiar. At max, the range. For example, uh, if someone say that you don't go beyond this boundary. Okay, this is your maximum path. So that is a restrict here, that you don't go beyond this. So that we call that as upper bound. As we see in diagram, that this is our boundary. Okay, and what is this? This is our actual function, algorithm function. So after some point of time, and 0 is at that point where our what our function satisfy the big O condition. Big O condition is what? it's not go beyond this boundary. Okay, then after that it's going smoothly, means after that it is going till same way at what n0 condition. What is the n0 condition we see after that? So first to understand this is a this denote for time and it's denote for input size. Okay, so let's see the satisfy condition. As we see the satisfy condition, this is our what actual function time, algorithm time, or this is a what constant time. Constant time means this is a satisfy condition. Beyond this our function is not go, means it is we call as a upper bound. For fn we can write as a big O of gn. Okay, if condition is satisfied, then we can write like that, fn is equal to big O of gn. Okay, so let's see the example. After that you can understand very well what exactly I uh, want to explain for big O. So let's see the example in next slide. As we see here mention as a find the big O for what this is given that fn is a 3n plus 1 and gn is a n. So how you do that for this? So first condition is what? First I write the satisfy condition that c is gn. Okay, n0 is what? Greater than n, n is greater than, sorry, n is greater than n0 and c 0 greater than, and next is n0 is 1. Okay, greater than equal to 1. Okay, this condition need to be satisfied. So let's see what we do here. First we see in which condition our is to be satisfied for n. So let's see put n plus 2 is equal sorry, greater than uh, less than n. Okay, so here what value I put here? So you know here is gn. Let for this I just make like that so that you can understand very well. Okay, now see, here c is there. Okay, this fn condition, this is gn condition, this is c. What value I put here? C, so that this constraint to be satisfied. So if we put c is equal to 3, see that if you put c is equal to 2, if you see 3n, is any condition that cn plus some value is what? Less than cn? No, it is totally wrong. So if I put here 4n is equal to c is equal to 4, yeah, it's somewhere right, somewhat right. Let now I got what value of c? I got a value of c. Now is which value of n0? What n0? The value to be satisfied. So let's see. Let put n is equal to 1. If n is equal to 1, the 5 less than 4. No. If n is equal to 2, then what is this? We say that 3 6 8 greater than 8. Yeah, here is right. Now next put also 3 for 3 also. 3 3 3 3 is 9 11 and 12. Yeah, after the condition is satisfied, where is start from satisfy? For n is equal to 2. So we can say that for n greater than 2 and c is equal to greater than equal to 2 and c is equal to what? 4. These two condition, then our function what? Fn n is equal to big O of gn. Okay, So for this condition you can write like that. So now in this method, in this way, you can what make a big O, find the big O. So I hope you understand how you make this big O, and it is easy. If you find some other questions in internet, and if you find any doubts, so please comment below. I will definitely help you for this. Now next we're going to next notation, that is called big omega. So what is a big omega? So same like where is mentioned like this is lower bound. Oh sorry, that time is I mentioned as upper bound. Okay, now it's the lower bound. The upper bound we call also called as a what, worst case, and this is also called best case, best case. Okay, okay. So this is the same like condition, but here what, here gn function is low and fn is greater than this. Means what is this? If you going somewhere and someone said like you at least do that work, okay, at least you minimum do that, after that you can do many more. Okay, this is the minimum condition you can do. After that you can do many more work, but at least two minimum. So same like it is the same like what big o, but there is a maximum condition. Now here is a minimum condition. So if you see same like that, there cgn ngo c0, same condition is there. And if you see that the diagram, cgn is there minimum, and this is your algorithm function that you need to be minimum satisfy this condition. After that maximum, you can do any what, any numbers. So let's see example. As we see earlier same example, let's see here also. So our condition is what here, fn is greater than what, cgn. Okay, gn, this condition to be satisfied. For this what we do, so here we what we do, let's see what, in which condition is to be satisfied. N plus 2 greater than c or what, n. So what value is satisfied? If we put c is equal to 1, okay, so c is equal to 1, yeah, it's satisfied because n is a list value and is 3n, so it's automatically automatically satisfied c is equal to 1. So first condition we need to start. Now what value of n is to be greater than n0? So let's put, if you put n is equal to which value, just pause the video and find the answer. So the n also what, 1. So for value of n0 is equal to 1, c is equal to 1, means n is greater than equal to 1 or c is equal to 1. Is this condition, for this condition our what, fn is equal to what we can say, omega of gn. Okay, so first condition is satisfied. Now check for second, is second is satisfy the condition or not. So before doing this, just what we do, we just remove this first question. Now we after that we start second. So guys, please like our channel for more videos, and I just make this video for gate purpose, and I also try to solve a previous year question also for gate exam. So please subscribe our channel to support me. And now go to go for next question, is this condition is satisfied or not. So same, 3n plus 2 greater than equal to gn, gc what, n square. Okay, so if we say either put c is equal to 1, no, is n square. If 2, no, so n square is a big term. Let's see c is equal to 1, I put here. Now put for n value, if n value is satisfied or not. Okay, if we put 1, then 5 is greater than 1, yeah, it's satisfied. Now we put 2, 6 plus 2, then 4, means 8 greater than 4, yeah. For n is equal to 2 also satisfy, n is equal to 1 is satisfied. Let's see for 3. 3 3 is 3 3 is or yeah, is the 9, 9. Okay, 11 also satisfy. Okay, now we put for what, n is equal to for 12 plus 20. Now you have, if you see that 4 4 is a 16 and here 14, so in this condition is 12. So uh, 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 for n is equal to 4 is not satisfied, so we are not unable to find for this condition for what, omega. So we are not unable to find omega for this question because we know already this is the n square. How our functions go beyond this, because it's already larger term and this is less. The n is what, smaller than n square. That's why omega condition is not satisfied. By seeing this, you are easily said that we can't able to find omega for this question. So let's go for next notation. What is this, big theta? So as we see that, I already told that three condition is there. What, worst case, best case, now it is the average case. And average case what is the finding between asymptotic lower between lower bound and upper bound, means either between what case, big O and big omega. So as we see that, this is what, which case is there, this is our what, big O. Okay, this is our what, big theta. Okay, this big O or big theta. So between this, what our condition is coming, big theta. This is big theta, this is big omega. So this is a big omega, a big theta, big O. Okay, so now we see big omega. The big omega is what, c1 less than z, or same condition there. If this constraint is satisfied, then we can say that there is a big omega. Let's see example. Same example here I consider. So how we do that? So here we already see that cn is equal to c2 cgn. Okay, so 3n plus 2 is equal to 4 n, and n is greater than equal to what, 1. Then after that we can say that 3 1 is less than 4n. This is our what, upper bound condition, where c is what is this, 4, c2 here I just, okay. Next, what, fn is equal to c1 gn, then 3n plus 2 1, oh, 1 n, then what, 3n plus 2 is greater than n. The what is the condition, n is greater than 1, and what is the c value, c value is to be 1. This is a lower bound, so we can say that yeah, it's coming between range. Yes, so we can say that yeah, what, fn is what, theta of gn. So it's a easy. If you see that, if you able to find for this condition for big O as well as big what, omega and big O, then you can able to find for big theta also. If both conditions satisfy, then we automatically, you can say that big theta you can also put that. So if you see that here in this question, if you see second one. So if you condition if you take this question for big O, big O, so you can easily find, because it's the maximum condition and it is a minimum condition, you can easily find that big O. But for big omega is not able to find. If big omega is not satisfied, means in two condition, one condition is satisfied and other is not satisfied, you automatically not find big O theta. So you're not able to find average case. So you easily understand. So to clarify this confusion, in next slide I show you different comparison. As we see that here, so here is what this is our what this is our tn, this is our algorithm function. If you see that this is what f fn fn, and this all are gn that we see one by one. So we know let's I write all conditions so that you can know, so you can usually identify this condition. For this, fn should be less than cgn, uh, big omega omega, the condition is greater than cgn, and uh, fn is equal to gn, means if both these conditions satisfy, then we easily find theta 0. And now see one by one. So if you see that 4n n plus 1 is what less than n factorial, that's why we are able to find. And if you see is not, that's why we're not able to find. If in both conditions not satisfied, automatically this is not satisfied. Similarly for this, yeah, it's maximum term, that's why it's satisfied. For this it's not satisfied. Similarly not satisfied, that's why it is also not satisfied. N square, the n term is what less than this, that's why it's satisfied. Is not satisfied, not satisfied. Similarly these are less than this, is satisfied, no, no. The explanation also is there below this, so you can see and you can what easily identify, but I also explained you that. Then now you see that, yeah, yeah, it's satisfied. And also for greater well, so also is satisfied. If both are satisfied, this is also automatically satisfied. Now see log n. Log n is log n. Is possible? No. And because n is bigger, that's why it's not satisfied. Okay, it's satisfied. Yeah, because log n is what less than, so that's why n is greater than log n. That's why it's satisfied. So both conditions not satisfied. That's why it's not satisfied. Here also same, one is not less than n. That's why it's not satisfied. But n is greater than 1. That's why it's satisfied. But it's not satisfied because both condition is not satisfied. Now you can easily identify the comparison between bigger theta and omega. So thank you for watching. If any doubt, please comment below. And thanks for watching us, and please support and subscribe our channel. Thank you.